Thank you very much. I hope you can hear me. And this is quite an honor for me to be in this conference. I would like to thank the organizer to invite me and also to organize this conference for the name of the Tamás Roska. So I will, when I invited to this conference, I decided to look to how the Tamás Roska affect my research and my life. That was my point to start to investigate before to prepare this slide. So for me, of course, there are many research questions raised by the Professor Tamás Roska, but this is the question affect me, my research, and also direct my research field. So the question is how to mimic the computational power of the networks in nature to solve the cutting-edge engineering problem. So the Professor Tamás Roska always dealing with the engineering problem. So the idea was to solving the cutting-edge problem, introducing a new methodology. And then the method he advised me to handle in fact, use mimicking the computation power of the natural network. So I met him first in 1997 during the conference. I was a master's student, and he was organizing the European Conference on the Circuit Theory and Design in Budapest, 1997. And first I met here, and also I met with Professor Jos van der Wallen. He's my promoter with Johan Sykens. So starting from 1997 to end, he always advised me about the research and give me good advices. So this is the picture, in fact, from my PhD defense. He was in the jury of my thesis, and during our discussion, not only in this meeting, also in the academical meetings and also project meetings and in the personal life, he was always directing me my research and giving the advice. So when I look to the link with me and the Tamás Roska, and recently I found that in our research lab, Circuit and System Chair lab, two of his papers, and in fact they are brought by Professor Ahmet Dervişoğlu, who is the good colleague of Tamás Roska, and these are the two papers about the nonlinear modeling. Both of them are in the Berkeley, and when I look this paper, I understand that his solid background on the circuit theory. In fact, his knowledge on the field make him a good mentor to me. So I will try to explain his research question and what I did based on this question. What is my contribution in the field with taking this problem as my research question? So his research question, in fact, to mimicking the computation power of the network. So this is one of the work explaining actually what's the active wave computing, which is introduced by the Professor Tamás Roska to our field. So in the retina, in fact, there are a group of cells, a network, and they generate a behavior, dynamic behavior. So this is no asymptote with stable output given for each input. So the image, in fact, on the retina generates a sepatotemporal wave. So his question to me that this biological network process the information and create features to brain, and the brain use this information to extract some knowledge. So question is how we can mimic this computation power. So what they did in the project of Dictam, the work of Ricardo Carmano and Rodgers Angel, and with also Tamás Roska, in fact, to create this network on the silicon and showing the dynamic behavior. So this is in fact to affect me a lot and to use the wave computing. But before the use the waves in the computing, the idea for me to generate a network to simulate this kind of dynamic behavior. So the Tamás always advising me to find a network, but it should be a practicable and implementable on the planar technology. One of the things I have to say about the Tamás Roska, he was a realistic person and a good engineer, good mentor, advising it should be implementable and should be applicable for the engineering problem. So this is a simple locally coupled relaxation oscillator, which is a CNN network, in fact. They are able to generate waves, separate temporal waves, which supposed to be used in the wave computing. So programming this network with a parameter, initial condition, input, and the coupling wave, we are able to generate the waves, different waves on the same network. So it was in fact a simple network, and it generates, playing with the parameters, we are able to generate a different kind of sepalotemporal dynamics. Just imagine that in the retina or other biological network, they are more complicated and they generate a lot of different dynamic behavior. So question is how we can use them in the engineering problem. So of course, when I present my work to Tamás Roska, he was always giving the idea on what they did in before and what they try in their research, for instance, fixed states, which is also one input signal or one feature. You can generate more dynamic.
Excuse me, Professor Yalcin, your slide doesn't change. So maybe if you could move the slides because you have access to your presentation, we do not.
Okay, sorry about that. I couldn't recognize it. So this is the waves, in fact, with using the fixed state, making the network inhomogeneous, and then to multiply the behaviors. So these are the later on can be used in the application to using the waves in the computing. Now, what will be the application? What will be the application? This is the one things we discuss a lot. So this is the path planning using the simple traveling wave. So in the problem, in fact, finding the path starting from a point to target using the wave computing. So in this application, we are only using the traveling waves, starting from the one point to target point. But the advantage here, the computing the wave, give you all the possible path to the target. So this is in fact the advantage of the networks or the wave computing. In this way, we are able to obtain the all possible path to the target. So these are in fact some advantage. So there, furthermore, during the especially IRIN programs, we present our research to Professor Tamás Roska and bring the more difficult problem like a hunt and hunter problem. So the idea is here to find to catch the hunt, but the question is measuring the possibility of the catching or estimating the catching point if it is possible, or estimating the time for catching. So these problems, in fact, can be computed at the same time using the waves we are generating on the media. So these are in fact, the research question come with from the Roska when we are discussing. But what I have to tell you that when I thought that why did I work in this field? Or in fact, the answer is we found ourselves in the Tamás Roska research area was his kind personality and sharing side. So I was lucky, in fact, to meet him in 1997 during the conference, and later on, with my luck, I had during my PhD, I had a chance to visit his lab and sharing the time with him and also his colleague. During all these meetings, his kind personality, in fact, attract me to be in a part of his research. And the sharing side is quite important because Tamás Roska was always an open person and he was always share his idea. When I asked some question, he openly answered my questions and always shared his idea. Today, Tamás Roska research question continue to be up to date with the new information obtained, understanding the nature. This is quite important. We are seeing in some new publication this fact, a new model of the physical system and the applicability of the new technology suitable for realizing this model. And in future, we will see wave computing, mimicking from the nature in the hard problem will be a solution. So I will thank you all. I'm so excited. Sorry for my my English. In fact, it is highly difficult and sensitive for me. And I personally very enjoy the time shared with the Tamás Roska, with my family. This is a picture we were together with my family in the Torino during the CNN conference, and it was always welcoming me, and it was very good time. It's in my memory. Thank you very much.